This problem we asked to find the domains of some common function. So there are three things we need to watch out for. The first one, denominator is not equal to 0. The second one, under the even root, had to be greater than or equal to 0. And log of anything, the argument of the log must be positive. Right, only those three things. Now, let's look at these examples. The first one we have that part. It is a polynomial function. It is defined everywhere, and it is not any of this. That one is a cube root, not an even root. So this is also defined everywhere. So all of this together, the domain is all real numbers. So from negative infinity to infinity. Next, we have a rational function. We have the denominator 2x minus 5, and that rule, denominator cannot equal to 0 because dividing by 0 is undefined. So denominator not equal to 0. We will add 5 on both sides and then divide by 2. So x not equal to 5/2. Now if we draw a number line, there's a 5/2 here. We can have anything on the right, anything on the left. So the domain of this problem, we write negative infinity to 5/2, 5/2 to infinity, and then link them by a union. Right. Next one we have this, and this is a square root. So under an even root is going to be greater than or equal to 0. So we're going to have this greater than or equal to 0. Right. Minus 4 on both sides. We have that negative 2x greater than or equal to negative 4 divided by negative 2. We have x, and that is 2. The only thing we need to watch out for is when we divide by negative number, inequality must be reversed. So that have to be reversed from greater than or equal to less than or equal to. So we will write anything less than 2, meaning on the left only. It has the equal sign, so we put the square bracket. So we have negative infinity to 2, the square bracket, because it has the equal sign. Right. Next, a little bit more difficult. First, we require the x minus 3 inside an even root or a square root. So first of all, we have to have that x minus 3 have to be greater than 0. So that's the first thing. X minus 3 have to be greater than 0 or equal to, I'm sorry, because that's just inside an even root. And the second one is the whole thing, the square root. It is the denominator cannot equal to 0. So put those two together. We will have just x minus 3. It could be equal to, but actually it cannot. So we just have greater than 0. Because if we square both sides, we have x minus 3 not equal to 0. So we cannot have the equal sign here because it is the denominator. Right, so it is just greater than, cannot be equal to. By the way, this is a polynomial function, so the domain of this is all real numbers. Not going to worry about that. This is all we have here. Plus 3 on both sides. We have x greater than 3, and that's pretty much it. So it's going to be on the right side of 3. So just say it, 3 to infinity, and this one, it is no equal sign, so we have to use parentheses. So the difference of these two problems is that the square root of x minus 3 is at the denominator, so it cannot be equal to 0, it's just greater than. Right, there are two more here. This is the problem where we have the denominator cannot equal to 0. So we solve for x minus 1 on both sides. We have x squared not equal to negative 1, and then we take the square root on both sides. When we do that, always have to have the plus or minus. The problem with this is we have a negative inside an even root, so that is imaginary. So x different than imaginary numbers, meaning all the real numbers are acceptable. So we just say all real numbers. And we just write negative infinity to infinity. Next we have the natural log of x plus 3. That is the third rule we have. Inside the argument of the log must be positive. And subtract 3 on both sides. We have x greater than negative 3. And it is on the right side of negative 3, but not equal to. So that's what we have. Basically, the domain of some common function we have is denominator not equal to 0, inside an even root is greater than equal to 0, and argument of the log is positive.